All right, welcome back. We're heading down the home stretch now. There's this one and one more. All right, so if you've been following along, yeah, you've been a trooper throughout all of this because these videos haven't been exactly short. So, with that said, let's go ahead and get through this, and I'll show you. I'm going to set up a Samba with Ubuntu. It is as easy as it is ever going to get for sharing resources over a network. So I'm going to start with the easy example. I am in this presentation. I'll go over some of the concepts, some of the things that you might run into. And then if you are a Alfred State student, we will be doing, at least on my laptop, so I'll at least show you a little bit more robust version of a NAS, right? We don't have the resources for a SAN. We definitely don't have a fiber channel to do anything crazy. So I'm going to show you what I can with the resources that we have, but for this lecture, this recorded one, I'm going to show you how to set up a Samba disk share in Linux, and that's going to do for most people that are actually watching this in the real world. So with that said, there are three types of storage systems. If we're talking about network ones, we have directly attached. They don't work very well. So directly attached is something along the lines of having a external storage system on your router or directly attached to your computer or something along those lines. It's not very good. You're relying on the USB protocol. Not very reliable. It's just, but if you have to use that, I mean, go ahead. But there are better solutions out there, okay? SAN, storage area network, network-based storage, typically used as a management server for multiple storage pools. So SAN is one of those things where you start getting into highly scalable projects and you need it for something very big. Yeah, it's going to be a big project, right? You're going to be in an enterprise environment. If you have a SAN, you got something serious going on, okay? So SAN is really cool, right? NAS, equally as cool, but typically it's a single device. It's a big storage pool, and it usually comes with some sort of software RAID. So the example that we're going to use in class, if you're an Alfred State student, is either TrueNAS Core or Scale. I haven't chose yet. I think I'm going to use Scale because it's Debian based. With that said, if you understand these three types, you're going to be good to go. Understand that most of the time, in most places, in most working environments, you're going to have a NAS and not a SAN. All right? RAID. RAID, depending on who you talk to, RAID stands for Redundant Array of Inexpensive Disk, which is what I was taught when I was coming through, or Redundant Array of Independent Disk, which I haven't heard anyone say that except for on CompTIA exams. So it's out there. Someone has to say it because it keeps coming back. I haven't exposed to them, haven't been exposed to them. So I usually say the term of inexpensive disk, okay? Multiple physical disks combined into a single logical disk, okay? So we'll get into that a little bit more later. So what this allows us to do, which we'll get into what the RAIDs actually do, is it gives you a software overhead. And then with that processing ability, it gives you the option to store your data in a particular way, depending on what your goals are. So you can be as performance heavy as a pure stripe, and you're just going to stripe all your data to all the disks, or you can be as redundant heavy and just mirror all your image or all your data to all the disks. Obviously, that's on the extreme end of both of those. Both of that pendulum swing is the extreme end. So with that said, let's go ahead and go over those RAID types. RAID 0, stripe, no parity, pure performance increase. So read and write both ways. RAID 1, mirror. The only performance increase you're going to get is from reading at this point, but writing is the same performance. RAID 4, block striping, 1 parity drive. Okay. RAID 5, block level stripe parity. Okay. Performance increase, both read and write. Sort of. So your parity drive is going to take away your a little bit of performance overall, so it's not going to be the same performance of a pure stripe, but it's going to increase. Okay. RAID 6, block level striping, 2 parity blocks. Okay, the same thing, just you're taking away 2 disks instead of 1. Hybrid RAID, this is where it's really interesting. You're going to double up on your logic, which has overhead cost to it, but if you're looking for that performance increase with reliability, a stripe with mirror is going to be your solution there. Okay. Now you can go the opposite way. RAID 10, a mirror with stripe disk is not going to perform as well though. Okay. NAS versus SAN. I've already rambled on a bit about this. So a NAS has a file level access storage system. So this means your permission systems are going to be based on files and folders. Your access is going to be based on files and folders. So you're not going to have access to the block level, so your sector level, the disk itself. So that also means that you're not going to have access to formatting that drive. You're not going to have anything disk related. You're not going to have an option to partition anything. You're not going to have an option to, anything that is physically oriented with the disk, you're not going to have access to that. You only have access to the file or the folder, which is technically a file. Okay. SAN, you have block level access. Client managed space is like a local drive. Okay. So protocol wise, that is a primary difference. If you want to do something like this, where you had a bunch of developers and then you want to give them block level access to a disk so they can sandbox particular software, then a SAN might be the option or the way to go for that. Typically not. You generally don't need a SAN. If you're going to do something like that where you want to give them block level access, almost always they're going to have their own disk on a local machine for their development box. Okay. And the last thing I want to talk about SAN, you can boot from a SAN drive if you want to do, because you do have block level access. So that is a cool thing if you want to do something like that. So yeah, there's your opportunity to do a thin client if you didn't necessarily want to do thin client software through something like VMware. So with that said, NAS protocols, CIFS, Common Internet File System, created by Microsoft, and it was replaced by, well, it is SMB with a different implementation. Okay. SMB, Server Message Block, created by IBM. SMB3 has replaced CIFS. Okay. SMB is basically the standard that we all use for network shares. The reason for this is because SMB works on both Linux and Windows. If you just have a Linux environment, NFS, Network File System, will work. However, in my experience, when you do something like that, and you essentially go, no, we are not going to be using a protocol that is more flexible, it will always get you every single time, because there will be a scenario 3 years later where you go, oh, okay, yeah, we definitely need window clients to be able to access our network share. So now we got to go change everything. Yeah, in general, if you have the opportunity to have a more flexible and robust network and system in general, go ahead and do so, especially if there's no cost involved. There's almost no reason to not use SMB. But I have to tell you about NFS just because if there is probably security, I'm not real versed in security, I'd imagine this would be more secure. All right. SAN protocol, fiber channel, FC. Okay, right, self-explanatory. iSCSI, quickly becoming legacy. You're going to run into this occasionally because it had performance for a long time. It doesn't have the storage like you would expect in today's enterprise environment, but these things still exist. They're still around. Okay, fiber channel over Ethernet. You're sending that fiber channel protocol over the Ethernet. Self-explanatory. NVMe of, I haven't seen this used in practice. It's got to be done somewhere, but it exists. So again, this is one of the things that you need to know that it exists. You can't be completely oblivious that these protocols don't exist. SANs, we do not have the resources here at Alfred State to show you what a SAN is. One day, maybe. We have other priorities that we got to accomplish first, but be aware, use this as a reference, right? SANs is a thing. You don't have much exposure to it. We do not have the resources to expose you to it. SANs is a thing, all right? Creating a NAS in Ubuntu. Okay, so we're going to actually do this example here in a few minutes. So installing Samba, make directory, Samba share. So this is my step. I like dedicating a folder to a Samba share because you don't necessarily want to share the entire thing. However, this example, I'm going to share the entire home folder. Okay. Configure. Great. Awesome. Let's go ahead and do that now. So let's go ahead and clear this. I have my terminal up. That looks awfully small. So let's go ahead and make that bigger. Here we go. So let's go ahead and walk through this real quick. So we are going to do sudo apt update. So the reason why we're doing this is because when we install a package like this that is dependent on other systems, we need to make sure that what we're doing is actually updated and that we don't have an old version of, in this case it's Ubuntu, but any type of Linux distro. Now we can install Samba like so. I do want to install all of this. Okay, so that is done. If you're following along on the Ubuntu tutorials website, which is actually very good, this is the part where they tell you to make a directory for a Samba share. I'm not going to do that. The reason for that is because I'm going to share the entire home folder. My entire home folder, so Briggs.ja. Okay, so what we're going to have to do, now we need to alter the configuration for that SMB config file. So we have a couple options here. Nano's default. We've been using code up to this point. So I'm going to use code just because it's a little bit easier. And then you get some other helpful tools with code as well. So etc samba smb config. This is where that config file is located. We're going to open that up in code. We are going to come all the way down. We're not going to alter anything that's in comments. We're going to give this a little bit more space. We're going to give it a comment. So there's our comment. This is going to let other developers know if they're working on this system that this is the share for Briggs.js home folder. Okay, so let's go ahead and do this. Briggs.js. So this is going to be the username that when you're prompted to log in as, this is what you're going to need. So I've done this as computer names in the past, which my computer name for this right now, I believe, is Maru. So I've done it like this as well, but it is better to do this for the usernames just in case you have multiple users on the device. Okay, so if you're using this at home for your laptop, obviously there's only going to be one user. Well, maybe not obviously, but generally speaking, there's only one user on a device, so you can get away with using the computer name as well if you needed to. So we can put a comment here. Like so. Home, Briggs.js. So there's our path. Read only equals no. Okay, so this is going to allow us to actually manipulate files. So if we shared this and this read only was yes, then we could view the files, but nothing else. Okay. Browsable equals yes. Okay, so I hit Control S here to save it. Code does not open this in sudo, and it doesn't allow you to anyways. So it does allow you to do this. Retry the save as sudo. So I'm going to hit that. I'm going to put my password in. And that is now saved. So we come over here, we close that, we come over here, other locations, and SMB, wrong way, Maru, and Briggs.js, that should be right, registered user, password, that did not work. I'm pretty sure I'm missing a step here. I'm missing multiple steps. Okay, so let's go ahead and open up that terminal again. My fault. Got ahead of myself. Okay, so we got that. We changed our config file. We need to restart the service for Samba. And remember the D is a daemon. So this is a service. Okay, sudo ufw allow Samba. Awesome. And now we have to set up that password now. So Samba password D, all username, which is Briggs.js, new Samba password. There is that. So I should be able to go back here. So what happened last time, and I didn't explain it at all, really, not even poorly. So if I come over here, last time what we did was SMB. SMB, I'm telling Linux, this is the protocol that we're trying to use to attach to a network share. SMB, Maru, which is the device name itself, and then I'm going to log in as that username, that network share, so Briggs.js, so I'm trying to access that home folder. And because this came up last time, that Samba share was working. Now, I still want to be a registered user, and I just set that password, so this should be correct. And there it is. So we got desktop, documents, downloads. So this is my folder. So if I open up this again, and then I just do ls tilde, which is the home directory, it's the same thing even with the test folder. Okay, so this is exactly the same. Now, to be clear, there's no point of trying to network share and then connecting to your home drive on the same computer. There's no point. However, it does demonstrate that it's actually working. So that's what I was going for. But now, if you're on the local network and you have those credentials, the BriggsJA, and you know the computer name, which happened to be Maru on this one, and then the password, then you can access your files on the network. Ideally, it's going to be a local network. And then if you have a VPN, you can VPN to your home network and then get to it that way as well. So with that said, that's going to wrap it up for this presentation. We have one more, and then we're going to be done with the recorded lecture series. See you in the next one.